All right, Matthew, here we go. We've got lesson 9-1. We're going to add and subtract polynomials, which you've probably done in another class. We're just going to talk about some of the terminology that goes with it that maybe you didn't learn in other classes. So our question for today is to describe and correct this following error. So I've got negative 4m to the third minus m squared plus 9, and I'm going to subtract 4m to the third plus 6. And I think the answer should be negative 8m to the third minus m squared plus 15. That is wrong. That's not the right answer. So what is the error that was made, and what would we do to correct it? So here's our terminology. A monomial, mono meaning one, is a single term. Okay, so when we are looking at that, that could be like a number, like 6 or negative 10. Those would be constants. You know, we would call them constants because they don't change. So 6 and negative 10, we would consider those to be monomials. Now, variables are also monomials. So if you had like x or n, those would be considered to be monomials as well. And then next, a monomial can be the product, which means multiplication, of numbers and variables together. So maybe we had 4x. So that's a number times a variable. That is a monomial. What if we had negative 2, x to the second, y to the third? That's also a monomial. Everything's being multiplied. So we would consider this one single big term. So monomials, they're just one term. Polynomials, poly meaning many, is when you have monomials that are added or subtracted to each other. Now, they've got a couple of them that are special named polynomials. So if you've got a polynomial that has two terms, we would call that a binomial, bi meaning two. So 2x plus 5, that is a binomial. 2x is a term, it's a monomial. 5 is a term, it's a monomial. So we got two terms there. We're adding them together, so add or subtract. And so that would be a binomial because it has two terms. A trinomial would have three terms. So that might be something like x squared plus 6xy minus 1. Okay, so I see here that I've got x squared, there's a term. 6xy, there's a term. 1, there's a term. There's three terms right there. So we would consider that to be a trinomial. Next part is degree of a polynomial. Don't sweat too much over this. What this helps us do is to put our answers in the correct order. We call it descending order is what we want. So don't sweat over this next part if you don't quite understand it. You probably already know how to do it. You just never called it degrees and stuff like that. But anyways, the highest sum of the exponents from the variables of a monomial. That's a lot of words. Here's what it means. We're looking for the sum of the exponents from a monomial, and we're only going to look at the variables. So let's look at this first term right here. So this is a monomial. So we want to find the sum of the exponents of the variables. Well, this variable has an exponent of 2. This variable right here has an exponent of 1. So this degree of this term is 3. This next one has a variable of x, and it has 5 for its exponent. So that has a degree of 5. And then this term here is a constant. There are no variables, so there's no exponents, so that has a degree of 0. Okay, so if somebody asks me, what is the degree of this polynomial? Well, I want the highest degree. So 3, 5, 0, the highest degree is 5. So this polynomial we would say is to the 5th degree. So that polynomial is the 5th degree. It's not really going to mean a lot right now, but we're going to kind of come back to this in a second. All right, so find the degree of the polynomial. So this is a trinomial because there's three terms. So over here, remember we only look at the variables and their exponents. So this is x to the first. So I've got 1, 4. We're going to take the sum of those exponents. So this has a degree of 5. This one has 3 and 3, so that's a degree of 6. And this one has 2, 4, and 1, so that's a degree of 7. So what would we say is the degree of this polynomial, this trinomial that we have right here? We take the highest, which is 7, and we'd say that's the 7th degree. Now, on certain polynomials, based on their degree, we have a name for them. So let's say if you have something to the first degree, your polynomial is to the first degree. So this one was to the 5th, this one was to the 7th. So let's say first degree. That would be what we call a linear equation. So if I had 3x plus 7, that is linear because this is a degree of 1, that's a degree of 0, so that's the first degree. We'd say this is a linear equation. What if we have something to the second degree? We call that a quadratic equation. Well, these are expressions, but just go with me here. Quadratic. So maybe we had something like 4x squared minus 16. So it's a degree of 2 here, degree of 0 there. So that's one's to the second degree. So we would call this expression a quadratic expression because this polynomial, the biggest degree is the second degree. So we would call these quadratic. Last one is when we have the third degree, we call it cubic. So if we had, I don't know, 3x to the third minus 2x plus 1. So this part's to the third degree, first degree, 0 degree. So we would say that's to the third degree. So anything to the third degree, we would call this a cubic expression. And if there was an equation, we'd call it a cubic equation because it's the third degree. You'll hear a lot of this quadratic coming up. And in Math 1, you did a lot of linear equations because all of your stuff was to the first degree. So as we get moving on through this second semester, we're going to be focusing more on quadratic functions, which means that we're going to see a lot of x squared in our problems. Okay, so in earlier math classes, you focused mostly on linear equations where your variables were just to the first power. Now we're going to start looking at what happens when the variables are the second power. That's what we do in Math 2, second semester. All right, we're almost done here. This is a quick one. Standard form, which we also call descending order. So in standard form, and this is how I want your answers to be placed, each term is placed in order from the highest degree to the lowest degree. All right, so looking at this, this is a huge polynomial with 1, 2, 3, 4, 5, 6 terms. There's not even a name. I'm sure there's a name for it. I don't know what the name for it is. It's just got 6 terms, okay? So on this one, if I want to put things in descending order, I have to look at the degrees first. And we go from the highest degree to the lowest. So let's write down the degrees. This is the first degree. This is 2 plus 1, so this is the third degree. This is 1 plus 1, so that's second degree. 2 plus 2, that's the fourth degree. 2, that's the second degree. And then 2 plus 1, third degree. All right, so those are all the different degrees. So this started off not in descending order because we're supposed to have the highest degree first, and this is like one of the lowest degrees. So let's look for our biggest degree, our biggest one right here. That's our biggest degree. Fourth degree right there. So if I wanted this problem to be written in descending order, that would have to come first. So I would do negative 9 x squared y squared. There's my first term. Okay, I've done that one. All right, next, that was the fourth degree, so let's do third degree. Uh-oh, there is a tie. So what do we do in terms of ties? Well, we look at the first letter, and these should be in alphabetical order. So right now, the first letter, they both have x's, so it's still a tie. Now, both of them have x to the second, so it's still a tie. Now, if one of them would have been x to the first and the other one would have been x to the second, the one with more x's would have won that tie, but they tied on their x's. So now we go to the next variable, y and z. Well, y comes before z, so we're going to put this one next because y came before z. So this one's third degree. We're going to do plus 5x squared y. So that one's done. Next, we can do this one because it's to the third degree also. So we're going to do plus 6x squared z. So that one's done. Okay, second degree is next. We got ties. Okay, so we look at the first variable. This one's x, this one's y. Ooh, x comes before y alphabetically. So this one right here, the 2xy, is going to become before the y squared. So we're going to put negative 2xy next. So that one's done. And then we'll do negative 3y to the second after it. That one's done. Okay, all I'm left with is the first degree, so plus 6x goes at the end. We are now in descending order. Biggest degree came first, lowest degree came last. In case of ties, go alphabetically. And then if one has more, like if they tied on the alphabet, then look for the one who has the most. So let's say that you had like x to the second y and xy to the second. Okay, this one would come first. They both have x's, but this one has more x's. They're both to the third degree because 2 and 1, 1 and 2, they're both third degree, but since this one has more of that first letter, we would put this one first and then that one second. So the tiebreaker is alphabetical. And then if we need to break the tie more than that, we say, okay, which one has more of, whatever letter comes first. Moving on. Combining like terms. The terms must have the same variables to the same powers in order to be like terms. And when we combine them, only the coefficients are going to change. The variables will stay the same. So this is adding a binomial with a binomial. So I'm looking for like terms. 3x squared and 5x squared are like terms because they have the same variable of x to the same power of 2. So those are like terms. So only the coefficients change. So I've got 3 and 5, so that is going to be 8x to the second. So what is this doing? It's just saying, hey, I've got 3x to the seconds over here, and then I got 5 more x to the seconds over there. So how many x to the seconds do I have? I've got 8 of them, 8x to the second. Okay, and then constants are like terms, so we can combine these, and we get plus 3. So 8x squared plus 3 is what that simplifies to. All right, next one. Be very careful. Your problems are not automatically in descending order where we see right there, they're out of order. So you have to make sure that you're combining like terms. Now my highest degree is over here, 3d to the third. Are there any other d to the thirds? No, there are not. So this is going to be my first term, 3d to the third. All right, that's 8d. Does that come next? No. Next is my second degree, and there's only one of those, negative 2d to the second. All right, now we're down to the first degree. I've got 8d and 7d. Those are like terms because they both have a d and it's to the first power. So I've got 8d's here, 7d's here. That's a total of 15d's. Sounds like a song. All right, lastly, I've got constants, 1, 2, 3, 4, and 1, 2, 3, 4. So I've got negative 2 and 6, so I get positive 4 right there. It's in descending. Look at that, it's beautiful. 3, 2, 1, no variables. All right, next, what if there is a negative in here? If there is a negative, this is like it's saying that there's a negative 1 out front, which means we need to distribute this before we start combining anything. So anytime you see a negative, that we're subtracting these two trinomials from each other, distribute the negative 1. So this one becomes negative 5x squared y to the second. This one becomes positive 8x squared y to the third. And this one becomes positive 11 x y to the third. All right, here's where it gets tricky, where we have to really look at what goes with what and kind of look at the degrees as well. This is 5th degree, this is 4th degree, 4th degree, 4th degree, 5th degree, 4th degree. So everything is either the 4th or 5th degree. So let's look at the two 5th degrees. Do they have the same variables to the same power? X squared y to the third, x squared y to the third. Yes, they do. So I can combine those two. So I've got 6x squared y to the third, and I've got negative 8 x squared y to the third. So if I've got 6 of them here and 8 of them here, that's a total of 14 x to the second y to the third. So those coefficients are the only thing that's changing. The variables are not. All right, next. I've got 4 and 4, but these are different because this is x squared y squared. This is xy to the third. Are there any other x squared y squareds? Yes, there are. So I can take this one and this one. They're both x squared y squared, x squared y squared. So I can combine those two together. I've got negative 3 and negative 5. That comes out to negative 8 x squared y squared. All right, next one, this is xy to the third. This one's xy to the third, so those two go together. So I've got 2xy to the third and 11xy to the third. That means there are 13 xy to the thirds. Last one. Okay, so here's the trick right here. Watch out for your negatives. So we're going to distribute these to each of those. And we end up with negative 2t to the second minus t minus 7. Okay, now we're going to look for like terms. So this is my biggest degree here, t to the third power. Are there any other t to the thirds? Oh yes, here is one over here. This is negative 4 and this is 1. So negative 4 plus 1, that comes out to negative 3 t to the third. Let's look for t to the seconds next. No t to the second. Here's a t to the second. And that's all of them. So I'm just going to write minus 2 t to the second. T to the first, do we have any? Let's see, right here, right here. Oh, and right here. So I've got 2 minus 1 minus 8. So 2 minus 1 is 1. 1 minus 8 is negative 7. So I have negative 7 t to the firsts. Lastly, I have my two constants. Negative 3 and negative 7 makes negative 10. So there I've got my 4 terms. They are in descending order because they're going from biggest exponent down to smallest exponent. And that is that. That is adding and subtracting polynomials, my friends. We are all done. Math hard. See you later. Bye-bye.